Hello, beautiful people. Welcome to C5 Academy. My name is Ashley. Always a great pleasure to have you guys here, and thank you for choosing to click on the link and watching this video. So today we're going to be speaking about a very interesting new topic that just came up in a recent couple of days actually in the world, which is the invention, well, the beginning of an invention, which is the ionic wind drive. I don't know if I said that correctly, but basically it's a plane that is powered without any engine or propulsion as we know it. So it doesn't have an engine, it's not powered by fossil fuels, and I think that is probably the beginning of something truly incredible in terms of technological breakthroughs in the aerospace environment. I just want to start very quickly with this quote that says, on December 17th, 1903, Wilbur and Orville Wright made the first sustained control flights in a powered aircraft. Back in Dayton, Ohio, the brothers found they had much to do to perfect their invention. While the 1903 Wright Flyer did indeed fly, it was unpowered and difficult to control. So the reason why I chose this interesting quote is because they, obviously you know the Wright brothers, the people that invented the first plane. However, that first plane clearly did not become our commercial plane. It had to be developed on by many other scientists and engineers and people that had to add their collective consciousness to this project. In a similar way, I think that what is happening now with the researchers at MIT is the beginning of potentially a new type of technology that will be able to power planes in a much more silent and efficient way and sustainable way, actually. Let's have a look at the quick article. So this is the picture actually of the rendition, an artist's rendition of the aircraft. You will see it in the video that we're going to share just now. And actually you will see the plane fly without any propulsion. It's actually quite amazing to see that. So it's engineers at the Massachusetts Institute of Technology in MIT said they have successfully flown the first solid-state airplane that has no moving parts and does not rely on fossil fuels to fly. The flight is a milestone in ionic wind technology and could pave the way for quieter and environmentally cleaner aircraft in the future. This is the first ever sustained flight of a plane with no moving parts in the propulsion system, said Stephen Barrett, Associate Professor of Aeronautics and Astronautics at MIT, according to the Research Center's news office. This has potentially opened new and unexplored possibilities for aircraft which are quieter, mechanically simpler, and do not emit combustion emissions. Nearly 115 years ago, the Wright brothers made history by launching the first man-made flight, a feat that ushered in human dominations of the skies. Ever since that flight, most aircrafts have relied on moving parts such as propellers or turbines to power them through the air. Now let's have a look at this amazing videos which will give you a little bit more on this technology, which I think is fascinating. Thank you. Let's have a look.
The future of flight shouldn't be things with propellers and turbines, and should be more like what you see in Star Trek, with a kind of blue glow and something that silently glides through the air. When I got an appointment at university, I thought, well, now I've got the opportunity to explore this, and started looking for physics that enabled that to happen. The sort of mechanism that I found that worked was ionizing air and then using electric fields to accelerate the air. What we achieved was the first ever sustained flight of an aeroplane that is propelled by electroaerodynamic propulsion, and that's also, by many definitions, the first ever solid-state flight, meaning no moving parts. Well, the idea is kind of it dates back until at least the 1920s, where a eccentric inventor at the time started experimenting with high voltage electrodes and thought he had discovered anti-gravity, which of course was not the case, but that set some of the initial groundwork on mechanisms for creating what's called an ionic wind in the atmosphere by having high voltage electrodes ionizing air and then accelerating the ionized air. So what we did for this design is to try and stick to something that looks somewhat like a conventional aircraft, but under the wing, rather than conventional engines, it has a series of electrodes, and those consist of an array of very thin wires at the front and then an array of aerofoils at the back. Now those thin wires at the front are set at a very high voltage, plus 20,000 volts, and that constitutes the source of ions. This is ionized nitrogen from the atmosphere. Now the aerofoils at the back, they're set at minus 20,000 volts, and so that creates an electric field, so the ions go from the positive to the negative, colliding all the way with neutral air molecules and creating this wind that goes behind the plane. And that's essentially how it flies. The flight was about 60 meters long, something like 10 seconds, so quite short. It was constrained by the size of the gym that we found to fly it in, lacking infinite money and time and just wanting to do things as quickly as possible. That was what was on hand, and so we just asked the facilities manager if they would let us use the gym. They forced us to create a very long and detailed safety management plan, but then we were able to go ahead. Many attempts failed because of various things going wrong, like structural failures, the power electronics frying itself. So there were many first days, but the first day that it actually worked wasn't a sustained flight. It was about 50% power, so it was a power glide. Until that occurred, we still didn't know 100% whether this was really achievable. But after that point, we knew that we were then within touching distance of successful flights, and the first sustained flights followed quite soon after, which were pretty exciting. It's probably the first solid-state flight of a heavier-than-air vehicle, and I think that has the potential to be a step that is very interesting. Of course, we don't yet know whether it will be practically useful and widely used, and obviously I hope it will be, and have an expectation there are a number of applications. There are definitely some limits. So one of the limits is the breakdown voltage of air, and that varies as a function of altitude. And we've worked out theoretically what the limits are to the thrust density, which is the amount of thrust force per unit area that's producible. Now, what that suggests is that in the nearer term, it will be easier to create smaller vehicles like drones, for example. I think the near-term advantage is probably in noise, especially if you think that perhaps in 10 years we might have urban areas that are filled with drones doing things like monitoring traffic, monitoring air pollution, or many other services we're yet to imagine. And drones today are quite noisy and irritating. Now, we wouldn't want our urban environments to be polluted by all this noise, so developing a way of propelling drones that's silent or near silent would be advantageous in that context. In many ways, it's much easier to make progress now than it was in the past. I mean, if you look at this wonderful aircraft behind us, which was the first ever transatlantic flight about 1919, I mean, people were risking their lives to make that kind of progress. Today, we're not risking our lives. We're able to test things using remote control without having to have pilots on board test vehicles. That means the vehicles can be much smaller, which enables us to build them and test them with less resources. In terms of how this fits in, I don't yet know whether you'll see large aircraft carrying people anytime soon, but obviously I'd be very excited if that was the case.
All right, and welcome back. Thank you so much for tuning in and watching this video with me. I thought that it was a very interesting feat that is currently happening in our world, and I felt like sharing this with you guys. Again, thank you so much for being part of this movement, for being the change you wish to see in the world. Keep being the change you wish to see in the world. The person that invented this amazing technology believed that he could be the change in the world. He believed in himself, and that's why we have these breakthroughs. So again, if you feel that you are possibly insignificant or that your contribution will be insignificant, then you have never created a puzzle. Have you ever done a puzzle where there's one piece missing? Hull, obviously. So you are part of an incredible puzzle which we call life and which we call creation in the universe, however you want to call it. We are all amazing, valuable and equal pieces of a giant puzzle which we are co-creating together. And the number one rule to play this game and to succeed at being the best puzzle piece is to logically be yourself as best as you can be. To be yourself as best as you can be, there are obviously many different practices that one can do outside of meditation and mindful practices. There's definitely a lot of amazing conscious discoveries that you can experience through yourself. And anyways, I just wanted to share with you that you are an amazing human being. I'm very happy to have you here on this planet. Even though I'm clearly not seeing who I'm speaking to, I feel who I'm speaking to, and that is what matters. So thank you so much for tuning in. I'm sending you guys lots and lots of love. Keep being awesome, and chat to you guys soon. Ciao.